Okay, you can. All right, that's fine if you can hear me, yeah? Yeah, can I confirm you can hear me, please? Just say it so that I can hear. Okay, thank
Yes,
you,
I can hear
Emmanuel.
you. I can hear you.
Okay. Thanks, Emmanuel. Thanks for confirming that. Okay, so how many people do we
Yes,
have
sir.
on board now? All right, good evening, everyone.
Good evening, sir.
All right, thank you very much. At least you can hear me. I'm honored to be sure that you can hear me loud and clear.
Yes, I can hear you loud and clear, sir.
All right, that's interesting.
Good
Okay,
evening, sir.
thank you for joining.
Thank you. My pleasure, sir.
All right, so in the next 1 minute, I'll get to talk about the event today and what we're going to do. So you permit me because I'm a bit busy with other items. I'll still be online while the speaker will be going on to continue from our program for today. Is the speaker is he there?
Yes, the speaker is online.
Hello.
Is it me? Good
Engineer
evening,
Mo.
sir.
They said he can hear me very well. So I don't know. Who said he can barely hear me?
I can hear you loud and clear.
Somebody just drop an emoji that he can't hear me. That's why I'm concerned about that.
Yeah, I can hear you. I can barely hear you from this end.
So maybe the problem is not from me, but from you.
Oh, my speaker is 100%.
Okay. So if other people can hear me and you're the only one not hearing me, then at least we know that you can. So it's
Can hear you.
okay. Olamide, are you here? With over 8 years of professional seagoing experience, he possesses diverse technical expertise gained across multiple vessels, including tankers, FPSOs, offshore support vessels, anchor handling, PSV, MPSV, and hybrid vessels. Olamide is a proud alumnus of Maritime Academy of Nigeria, where he's honored to have such an accomplishment professional service. So thank you very much for joining, and we are so happy that you honored the invitation to join the largest online community we're building, and we appreciate you for all the support given to other ex-cadets. So I'll just give a brief introduction of what we should know. Electrotechnical officer, yeah. So before you come in, before the advent of the what they call now like the modern vessels, we used to have all engineers as electricians. Whether you are once you're an officer, third engineer, you start performing act as electrician. So most of us that started the career way back, we were acting as electricians in our various capacity. One of the most interesting part of my journey was power distribution system. Boss, please kindly check your volume. I can't hear you. My volume is very, very loud. Olamide, can you hear me very well?
Yes, I can hear you. It's most likely a network issue on their end. So they should either refresh their Wi-Fi or something like that.
All right. So, just like I said, one of the important aspect that we learned over the time was power distribution system, where power from the generators pass through the bus bars, from the generator to the main switchboard, from the main switchboard to the substations, to the transformers, to various equipments, right? So various equipments now, they have feeders. If the generator is supplying as much as 1,000 volts, I don't know about that now, and you have some equipment that use 220, 750, so you need to step down transformer all in the line. So, but now it has gone beyond that aspect. Yeah. Now we're talking about program logistic controllers. We're talking about uh, automatic switchboards and a lot of them. So, for you guys to have this knowledge, you're fortunate to have him here. I will give you the next 40 minutes to go ahead with your presentation while I'll be on standby. And I'll come back after 40 minutes to say hi and then go. So thank you very much and do have a wonderful presentation. Okay, Olamide, you can go ahead now.
Hello, guys. Can you see my screen?
Yes, sir, we can see.
Okay. So, good evening, gentlemen and lady, if there's a lady with us. So, as Engineer Charles has clearly stated, in the old times, there were no ETOs, electrotechnical officers. But, as he said, oh, who is annotating the screen like this? Okay, please, let's focus. So, I mean, we used to have electricians, and, even before that, we didn't even have electricians. The marine engineers or mechanical engineers who had a little understanding of the basic electricals, because back then, there was no DC powers that were running up and down, or 4 to 20 milliamps for sensors and all of that. It was pure mechanical. I mean, those days were easier, but as technology will have it, everything keeps getting more complicated, more easy. Come back with my sound. Can anybody else hear me clearly?
Yes, I can hear you
Yes, I'm
clearly.
hearing you.
Loud and clear, sir. Please go ahead.
Mr. Agada, if you say there's something with my sound, just try to refresh your network. Sometimes the network lags in meetings like this. Okay. So, now I would like to, yes. So I would like to talk about who the ETO is. So ETO is an electrical technical officer. Usually with a background of electrical electronics, either bachelor's, higher national diploma, or diploma. It is required in the new modern day maritime sector, in the sense that we have a lot of automations now. We are moving from basic machineries to automation. And then when you have automation, it's not like the engineers, mechanical engineers, don't have the idea of how to go about it. But you need somebody who has this on his mind all the time and can react in a split second to be able to decipher it and resolve the issue or reduce the damage or downtime. Especially in the offshore situation, you need everything done fast. But in the old days, we didn't really have offshore, right? We had more of ocean going. And the ocean going, the idea was just to take the vessel from point A to point B and deliver your cargo within a period of time. So, I mean, there was no much of urgency in the maritime movement. But in the offshore, we are now talking. I was actually helping my uncle with. Who is online? Do we stop and wait for you? Okay, so in the offshore, it's a situation of you're being hired by a client, say Seplat, Mobile, Shell, whoever it is, and then you have to respond fast because any mistakes could lead to collision because you're going very close. And that's why we moved from systems that were less complex to more complex systems. That's where you see more of those situations, which now require automation, calculations, dynamic positioning, etc., etc. So that is that. I hope everybody now understands who an ETO is and why they are required now in the shipping industry. And because it's just the system, we are getting more complicated. The world is requiring more fuel, more exploration to be carried out. And as such, you are having those situations. So as we have said, electrical technical officer is responsible for shipboard electricals and automation, controls, system power generation and distribution, navigation and communication. So on most offshore ships, let's say mid-sized offshore ships, you have one ETO on board, which means he's in charge of everything. So when we talk about shipboard electricals, what we mean is when you generate power with your generator, your prime mover, which is usually a diesel-powered motor, can we stop annotating? Drawing all over, it's not so good. So when you generate power with your prime mover, which is an electric motor, I mean a diesel-powered motor, it goes to the windings of the alternator, which then generates voltage. Now you need someone who understands this inertly, right? Because if you understand the alternator, how it produces power, diodes, I could send you guys links to that later on. Diodes, how the DC power is being used to create alternating current, which we then use to our switchboards. I believe everybody here is either once a sailor or is planning to be a sailor. If you are never been to sea before, try keep in touch. Anytime you're on board vessels, which are in ports, we can help you visit the vessel and at least have a visual idea of what it looks like, right? So seeing is believing. Practical developed skill for us engineers, irrespective of your trade, electrical, mechanical. As an engineer, you should be able to comprehend your skill, and with your visual and practical experience, you should be able to know what's going on. So when you get it to the switchboard, you need to understand, if we have gen 1, 2, 3, 4, how do they generate power to the switchboard? What kind of breaker do we use to connect the switchboard to the generator? Most ships now in the offshore industry are using air circuit breakers. Air circuit breakers could be Schneider, could be ABB. I mean, branding is a different topic, but most of them are using spring-loaded air circuit breaker. In some cases, you could see other types, but the most common and, affordable one is the air circuit breakers. So that is one aspect of it, power generation and the electrical shipboard system. When we move down to automation, automation is basically making it, in some cases, easier for the human factor. So, I mean, my first ship when I was a cadet, electrical cadet, although I joined as an engine cadet, there was no electrical cadet at the time. So we were opening valves manually. So you need to ballast, you have to know which valve to open. You needed to pump fuel, you needed to know which valve to open. There was filling and all of that. Filling and discharge valves. So you need to know what valves to open. But right now, the ships I joined now, oh my God, so automated. You sit down in the control room and then you open the valve that is in the aft. So it is about feedback, signal input and feedback and all of that. So definitely, if you're using that kind of system, which is not a mechanical system in most cases, because you can also create a mechanical system that does that, where you have pneumatic valves. But even at that, you need an electrical system that will give the inputs to the valve, sometimes solenoids and stuff like that. You still need electricals. So when you have that kind of level of automation, you need someone that understands it and is always at his fingertips. So it's not like other engineers cannot do it. It's not just at their fingertips. In my opinion, it's not just at their fingertips. And most of the time, you need it fast. You need it done because it's a ship. It's a high-risk environment. It's a professional environment. You need things done instantly. So initially, I remembered when I started my career, you could see other sailors from other countries were always like, oh, Nigerians don't do ocean going. We only did offshore. And they said offshore was easier and everything. But now, in this day and age, where you have vessels with DP2, DP3, you can't say that offshore is easy anymore. You have drill ships, so you can't say that anymore. So also, let's go down to power generation. Power generation, like we explained, is still fall down under the shipboard electrical systems. So power generation from the generator to the switchboard, from the switchboard, it has to go to sub-distributors because the switchboard is just the main place where all the power comes before going to the distribution boards and distribution boards. So for example, let's say you're on a ship like, which is the generators are generating 690, for example. Most of them don't go above 690 for normal offshore ships. When you get the 690, supposing your major machineries, let's say your seawater pumps, your cooling water pumps, your freshwater pumps, your sewage system, your AC compressor, your air compressor, these are things that, every engineer that has been to sea or has attended any college, maritime college, should know about. You know what they are required and what they're used for. Let's say all these units are running on 440, but your generator has generated 690. Can anybody write me in the comments what you think we will need to get this 690 voltage that's generated, we have generated, to the 440 that we require to run our AC compressor, air compressor, dry bulk compressor, seawater cooling pumps? Can anybody write for me in the comments? Because I'm reading them now in the chats now. If you can do that, I'll just give you 10, 20 seconds to respond to that, to see if everybody's listening or not. Very good. Very good, Insika. Thank you so much. We need a step-down transformer. A step-down transformer will be the major thing we really need because it will be able to reduce that 690 volts to 440. And once it does that, once it's able to do that, we can then direct it to a distribution board where you can tap for individual equipments. So at least now we are aware that we need a step-down transformer, and you know that it's definitely going to a switchboard. Now, how does a step-down transformer work? It's basically using winding, whereby the voltage on the primary side and the second, I think this is basic physics, SS2 physics, in my opinion, SS2 physics, how a transformer works. The winding on the primary side will be higher than the winding on the secondary side, depending on the configuration. Since we are talking about a step down here, the winding on the primary side, which is the incoming of the 690, will be larger than the winding on the 440 side, which means it is reducing. So 690 will be bigger, 440 will be smaller because it needs only 440 to go out. In my opinion, it's easy. So once you understand that, you don't need to run around when once you know your generator is generating and there's no power to your AC compressor. Oh, this AC compressor runs on 440. You don't need to run in circles. You know that, oh, from this switchboard is definitely going to a step-down transformer. From that step-down transformer, it has to go to a distribution box. Once you know it's going to a distribution box, you just need to run around and look for this. As an ETO, what I do when I join a vessel, personally, is an old trick I learned from my mentors, because I also have mentors. When you join a vessel, you go around. First thing first, know where all the distribution boards are, the boxes, where they are, know where all of them are. Write them down if possible. I mean, in modern days now, we take pictures of them. You know that distribution 1 to 10, this is their location. Distribution 1 to 10, this is what's in them. So if you do that, when a light trips on deck, you know where it is. When the galley tells you, oh, the booking range is not working, instead of you running helter-skelter around the whole ship, first thing, make sure the main breaker on the switchboard is running, then check it's on, and check the distribution box. If it has tripped, you know, oh, it has tripped. For safety, and in a situation whereby you're new on the ship, the best way is to go to the galley first, have a visual inspection, see if they have poured a lot of water into it, because electricity and water they are not compatible, right? They are not compatible. So you can't just go and turn it on and risk somebody's life. It's not going to be safe. If you are an electrician or a mechanical, marine engineer, whatever you are, at that point, you have breached safety. If you just turn on the breaker without ensuring that, oh, there was no good conditions for you to power that on. Obviously, it tripped for a reason. If it tripped on overload or a short circuit, then you are aware of it, or it has occurred several times, then you can do that. But of course, not everybody is perfect, but we should make efforts to make sure we take all the necessary precautions. I think that's enough on in power generation and distribution. Navigation and communication. As you can tell, basically on the ship, anything which carries electrons where there is a wire and there's power going from point A to point B is the ETO's responsibility. Even an electrician is responsible for that. As such, when you come to navigational equipment, you have radar, you have AIS, now we have so many things. You have DP systems, you have a lot, GPS, EGDIS, all these things, especially in the offshore. Even in tankers now, we have them. Now, and the communication, radio, telephone, intercom, all those things. You have all those systems. Now, navigational systems, most of them do have dual power. So you have the main power supply and the emergency power supply. The main power supply is should, in case you have a failure in power, you need to have a second power supply. Most of the time, they are always split on different sides of the bus bar. So on one side of the bus bar, when the bus tie is open, you also have the other side that is powered. Why? Navigational equipment have to be always on to prevent accidents, to prevent damage to the vessel, grounding, and generally for safety. Navigational equipments are very paramount. That is why when you have a navigational equipment issue, you don't have an electrical engineer on the bridge or even an engineer. They have basic science knowledge, but their focus is more on the navigational system, on how to navigate, how to maintain the rules. That's why sometimes you notice that, oh, some bridge officers just pick up the phone and call the ETO. Please come to the bridge, no matter how little it is. Even when they head the breaker trip equipment, they call the ETO. You don't need to get upset. You don't need to feel bad. Go there and resolve the issue as fast as you can. Politely do your job and walk away. Why? Because the man who is trying to navigate, who is trying to do his job, trying to make his records, hand over to his colleagues, your electrical systems or the idea of science is not in his mind at that point in time, is not on his fingertips. But as the ETO, because in the beginning you have visited all the distribution boards, both the ones on the bridge, in the accommodation and the engine room, you know where, or have an idea where the breaker is. If you have seen it before and you can remember, or you have written it down, or you've taken a picture of it, you will easily remember that, oh, this is where this thing is, or I think it is here. And when they tell you, oh, GPS has failed or AIS has tripped, first thing you go, is there power supply? Then you check, is the antenna connected? Then you check, oh, is the screen damaged? Did somebody spill coffee on it, water on it? So when you look at all of these things, you'll be able to know that, okay, this is the situation going on. Communication as well, that's the intercom system. Most of them use amplifiers because of the kind of signals they generate, audible signals. As such, if the amplifier is bad, usually there are about 3 to 4 amplifiers on every ship for that, because they use them for also public address system, and it's a ship, so it's multiple. We can have up to 150 phones. They are not really problematic, except the ship is old and then maybe you've not gotten some dry dock in a while, or you've not sent you any specialist. But the slightest thing you can easily do as an ETO or electrician, or even as an engineer, is to check, are the amplifiers on? Are the components in the amplifier good? You can just isolate it. Well, isolation means, of course, I believe everybody understands, but isolation means you take off the power, ensure that it is safe to remove. You remove the box, the amplifier box. It's usually like it's like a big DVD, but stacked, thicker than the DVD, a bit higher than DVD. You open the box cover you open the box cover and then observe. If you see any burnt component, capacitor, resistor, thyristor inside the unit, you know that, oh, this is damaged. If you have the spares and you have a soldering machine and you are good at it, it's easy for you to solder it out and solder a new one in. That really helps. So there was even the sound powered phones, they use 24 volt most of the time. I have not seen any of them that use the 220 volt. The sound powered phones, sometimes they are bad. It could be the mouthpiece, it could be the speaker on the ear that is not working. It's easy to open the phone, check. These things are crucial for us. As an ETO, this should be part of your weekly checks. Go around, use the steering room, check. It is not meant for only the ETO. Everybody on the ship should check, because God forbid something happens. We need to be able to communicate with the bridge. You need to be able to call for help. You need to be able to inform about the damage or the risks or the potential damage or potential risks of this happening.
Ola, excuse me. Please, who's doing this to the screen?
John,
Now, I am be mature, please. Thank you.
So communication is very, very important on the ship. It is one of the key things that you need to do. Is on the checklist for safety. If any inspector is coming, if you notice your class surveyor is coming, your pre-hire inspector is coming, they always tell you, oh, call the bridge from the emergency generator room, call the bridge from the steering room. So these are key points that everybody needs to know. And if they are not working, let's bring it to the notice of the electrician. If the electrician cannot fix it, bring it to the notice of the chief engineer, so they find a solution to it, or at least log it as a defect. It is very, very important that we log defects on board, because if you don't log your defects and then somebody comes from outside the ship and you have been living on the ship for 6 to 8 weeks, it makes everybody there look like they don't know what they're doing. And in this new age and day when we are educated and trained people, we shouldn't be portraying ourselves as that. It's not good. I don't think it is a way. We have a great alma mater, which is becoming better day by day. We pray and hope we get to a better position. If there's any questions, I would accept them by chat. You could write them down in the chat about what we have spoken so far. I'm looking at the chat right now. Any questions about what we've said, I'm open to answer them quickly, so we can move to the next slide. Insika, ask question, or ask question. Any question about what we have discussed so far? Log defects, okay. So, Iman has said, explain more about log defects about log defects. Okay, so what I mean about log defects is you need to record your defects. So take it like this. In the house, let's say the main door, the key, when we try to open the door, they work. And we leave the door open. We keep one person for house worker. Now, you can't continue. It's not a feasible, a viable way of keeping your property safe, right? Anybody can walk in when the other person is sleeping or the last man is out. And it's possible I tell, oh, Emma, you stay at home, I'm coming. And then you get a call shortly after I leave, maybe 20 minutes after I leave, and you say, and the person say, oh, I need you at the gate, I need you at the gate. You leave the house, and then somebody walks into the house, pick a few things, and then take off. That's not it. So now that door is a defect. Who do we inform? We inform the father of the house or the leader of the house and tell him that, oh, we need to fix this thing. We need to fix it. And everybody knows that we need to fix it. Now, as an engineer, once you have made it known to your chief engineer, he has a personal duty to fix it. If he does not fix it or he does not take it seriously, he needs to make a requisition. If he cannot take it seriously, you have to find a way to put it into a safety part of it, especially when it's safety. You tell your chief officer, tell your captain in a polite way that doesn't indict your chief engineer, that doesn't put your chief engineer in trouble. There's a lot of emotional controls that are way you have to handle situations on the ship to make sure you don't offend anybody or cause any harm to the person. Some people have unbelievable egos and all of that, but you make sure that you are fair and just in your way. So logging of defects is make sure that the defects is recorded. You can write it down in your defect list. Every ship has a defect list. It might be hidden, it might be deleted. Every ship has a defect list. Once you have that defect list, the first question is, oh, I have that the door key is defective. Imagine in the house, what are we doing about it? Okay, maybe there's no money to fix it now, but we are planning to fix it by February or by February month end. Once you get the money, you have to call the locksmith. So on the ship, imagine a valve is defective and then you are offshore. Maybe your sea chest valve, at least every mechanical engineer understands that. But you know that your sea chest valve, you can't take it out, maybe because the isolating valve is also not in good condition. What you do is you write it in a defect list that, oh, this valve is defective. And then plan for it for dry dock. Or anytime you are not in operation and you feel you can take the risks, you have a submersible pump or a Kaman pump that can pump out the water to overboard, the excessive water that will come in. Then you take on that job, especially you need the spare valve on board. So they need to buy that valve way ahead of time. Way ahead of time. Minimum, in my opinion, a month before dry dock, your valve should be on board already or should be requested for. So when you log your defects, usually it's always in an Excel sheet, Word document. That is it. I hope that is clear for you. And Ima, I hope that is clear. If it's clear, just give me a thumbs up in the reaction, please. And then Emmanuel says, what's the roadmap? Emmanuel said, what's the roadmap to being an ETO as a new person with no experience? So I would throw this back as a question to you. Is the roadmap with no experience is this: you have to have some electrical background. Why? You have to have some electrical background because even if you come on board as a trainee ETO or trainee electrician, cadet, whichever position, you can stay on board, work with the ETO, work with the engineers, and learn all of that. But when you get to your licensing part, that's when you have gotten minimum of 12 months seat time. I think that's still the required standard, 12 to 18 months seat time, depending on the country you go to. You still need an electrical diploma, HND, or bachelor's degree to present because they want you to have some sort of studies, some classroom experience before you can be able to take the license. So if you don't have that, then you might have it very difficult. Some guys even go with in the past, some guys went with the computer electronics or something like that, computer engineering, and then they got it, but it was a lot of rigorous questioning and all of that. But as the time is going, everybody's realizing that some people even go. In the past, some guys have gone with some HNDs that were not, good, and then they're not performing. It's life. It's possible to pick people like that, but there will come a time whereby ETOs will be required to take exams again to get to renew their license. There will come a time like that. Or there will come a time where they will require only bachelor's degree holders to be able to take the ETO license. I hope this explains your question. Also, there are two classes of ETO license. There's a ETO license regulation 3.6, which is for the ETO officers, and there's ETO STCW regulation 3.7. It is for ratings. So you most likely work as an electrician, but obviously you work like a rating, so you most likely have another ETO above you. I think Ghana offers the 3.7 now, and I think most of the people that went to Croatia, they also got the 3.7 also. I don't think the UK offers the 3.7 anymore. But yes, Ghana was offering the 3.7 the last time I was there. And you say, how do you record it? So like I said, your ship management should have a defect list. If they don't have it and you're on board, you make a defect list. Put the name of your vessel and write engine room defect list or bridge defect list. They should have, both deck and engine should have a defect list. That way, you are able to track what is defective now and what is defective in the past. So, for example, if I join January, I stay 2 months and I don't record any defects. Or I record 5 defects. Maybe I saw it, observed, let's say I observed 5 defects. I didn't write it down and I left in February ending. And then you come into the vessel by March. And you come in by March, you don't see the defects that I see, and you stay only 6 weeks. That does not mean the ship doesn't have any defects. The defects are there, but they were not recorded. So you have to write it down in black and white, be it digital black and white or physical black and white. Digital black and white is, Word document or Excel document. Physical black and white, paper and pen. You must write it down. It must be recorded. If anybody comes on board your ship, pre-hire survey or a class survey, they will always ask for a defect list. I hope that explains your question. Please, if it does not, just send me a message in the chat. I don't understand the shipboard electrical system. This question is vague, but Asita, sorry for pronouncing your name wrongly. Please just send me another chat. Tell me what you mean. Do you mean you don't understand how power is generated or how it is distributed? Anything like that, just let me know. Low voltage when a load is switched on. Okay, good. Your question, Hosanna, your question is what in respect to power generation, what is the cause of low voltage when a load is switched on? So, except there's something defective with your generator, usually when a load is switched on, for example, look at it as just watch my hand, right? You see, my hand is like this. There's no weight on it. But the moment I push on it, it has to dip a little before coming up. So that means when your generator is generating 690 volts, and initially there's no load on it, you have not turned on any motor, any electrical equipment. Nothing has demanded from that generator to produce power yet. But the moment you turn on your AC compressor, there is an inertia force from your basic physics in secondary school. I think the inertia is this. The compressor is in sitting state, cold state, or cold start, like your car. It's not moving. It's metal. It is sitting. You need to overcome that inertial force that is keeping it in place. So once you do that, the rated power that you might have requested for, they might be rated at 100 watts or 100 kilowatts or 2 kilowatts for that compressor. When you initially start that compressor, it can go even as high as 4 kilowatts for that compressor. Why? It has to move it first. Then after it moves the first 2 revolutions, it becomes free. So that is what will drag power from your generator. So it brings it down a little. Ideally, in an ideal situation, it should not take the load too low. If it's taking the load too low, something is wrong with your generator. It is already showing you signs. You need someone who understands the system to investigate. In this kind of situation, when you have low voltage, most likely your AVR is the problem. Your AVR is automatic voltage regulator. It's supposed to complement or reduce the voltage in a situation like that. So when the generator is loaded or there's a power demand from a unit from the generator, the AVR is supposed to tell the generator, okay, increase more so you can meet up with the demand. Reduce a little bit so you don't excessively load your equipment. I hope that is clear, Hosanna. Please, I want to know what are the components of an electrical shipboard and control system. Oh, there are so many, there are so many things to know there. I would mention a few off the top of my head. So you would have, like I was explaining earlier, the generator will be wired. Generator is the main power generator, right? It will be wired to a switchboard. Between that switchboard and the generator, you will have an air circuit breaker, which is basically like a big switch that you can use to put on the generator and put off the generator. What we are saying put on, we don't mean like power down the generator, like switch it off. What we mean is connect the generator's power to the switchboard. The switchboard is made of brass bars in an encased enclosure. So, I mean, this is diving down into electrical construction and maintenance. But I just wanted to have an idea. Now, those brass bars are tapped. They are tapped to molded case breakers. That's those small breakers on your shipboard switchboard. Those molded case breakers, sometimes even into miniature breakers, but miniature breakers are for lower voltages. So when you're using 440 or 690, which is the standard generated voltage on most switchboards, you use miniature breakers, molded case breakers. So if you, in your spare time, Ruben, this answer is for you. You could use check type of breakers. You will see air circuit breakers, molded case breakers, miniature breakers, etc. These are the most common ones on board. For control systems, so control means the thing that activates something else to work. For example, you want to open a valve in the steering compartment, but you're in the engine room. It is more of automation, right? Or control, depending on the situation. Some of them can use 24 volts, some of them can use 220 volts in that kind of situation. And in some rare cases, you can even go as high as 440, depending on the system. Now, for those systems, you usually have switches. They're more of switches, your PLCs, which are also switches, but they are in computerized ways, in the sense that, like now, we are all using these phones, laptops, and everything for this communication. How is it that when I push physical touch on L, that the screen is recognizing that it is L that I'm touching? There is a current that is passing from that L to the screen and then letting it understand in the computer's brain that, oh, it is letter L. So there are signals already coded to that. So it's like a switch. When you press it, it goes. Even your electric switch, once you click it in on position, it goes on. When it goes in off position. So it's just about wiring and understanding that. So I think for you to also understand this, you need to be able to read electrical diagram, basic, even with basic knowledge and symbols, you should be able to know, oh, this is a switch. So if there's a switch here and this line is, one line is coming in this way, there's a switch in between, and there's another line to the right, then if that means the switch can be operated. And if it's a switch, it can operate. If it's a diode, it would streamline the voltage to go in one direction. If it is a resistor, it will reduce the amount of current passing through. So basic symbols of electrical symbols, basic knowledge of electrical symbols can really help in your diagram reading and then understanding more of control systems. So let's move to the next question. I hope James Ruben, I hope this answers your question properly. So John Rec, what instrument do you use in testing for faults in the ship? John, you need to clarify on this question. You said using testing for fault. What kind of fault? Earth fault, insulation faults. What kind of fault? Please, I think you can edit your message. Just edit it. I will let you know. Good evening, sir. Thank you for this opportunity. Please, what is the difference between ETR and ETO? Because I find it confusing most times for applying for jobs. Also, what are the documents I need to use to work in line with the ETO? Haven't done with training role while saving to get my COC. So, Udonua, I think you should contact me directly for this. We'll talk about this. I have spoken about it already, but just contact me directly. I will drop you my contacts by the end. Can a mechatronics engineer enroll for ATO license? To be honest with you, this depends on the Maritime Authority, but because you have Tronic in it, and usually the countries where you apply for your license, they check what's the name of this list of things, your courses, the courses you took in school. They usually request for your list of courses you took from your year 1 to your year 4, and they observe it before they even issue you the license. Usually the process takes about a month. So I hope this answers your question for Captain V. Please, where do you keep /sit defect list? Official record of the ship. I mentioned this already. Do Lotto applies on board in case of defects? Yes, Lotto it applies. Any industry, in fact, in factories, abroad, Nigeria, everywhere in the world, logout and tagouts are required. They apply everywhere. It is very important. In fact, in a standard environment, you should have a logout tagout kit. There's a specific kit for each different size of breakers, valves, everything. The Lotto applies on board everywhere. So I'm trying to save time so that we can move on to the next screen. Does the AVR on board work on the basic excitation principle? And what is the excitation voltage? This depends on the type of configuration of your vessel. Some vessels use 12 volts, some use 24, some use 48 for the voltage. Excitation principle, I think you need to go and check what the basic excitation principle is. Then you'll be able to understand it. AVR is after all of that. Once you're already generating power, that's when it comes in. In the name, it says automatic voltage regulator. So it's not doing anything with the excitation, actually. It's after the excitation is done, then it does its job. In respect to what I asked earlier, you mentioned AVR. Can a generator start when the AVR is faulty? Yes, it's the same thing I just said in the last time. Well, also, when the generator switches off, whenever the generator switches off, when the load is applied, what is the fault to check or suspect? So you mean whenever the generator switches off, when the load is applied. So you mean there are a lot of things you need to check. First, what's the reaction? What's the alarm? Is it tripping on reverse power? Is it shutting down with low voltage? Visually you need to inspect. Is the voltmeter just dropping off? This is a technical question of which I can't answer you off the top of my head. You have to really just observe the unit. It's basically like a litmus test. Okay, Ruben. After the meeting, I'll take note of that. So Udon, Noah, and Ruben, no problem. Please, can one enter in by other departments just to obtain seat time, but going for an ETR position? So the thing is, I'm not a regulatory body. I cannot tell you, come into the industry, you will get it done. If it's not so I need to understand what other departments you're coming as. If you're coming in with a deck license, You and I mean, deck degree, you and I know that even if you take it to the Maritime Authority, maybe Ghana or whenever Nigeria decides to start offering ETO license, then you can, you can say that, but they will still not, they will question it because they want you to have basic electrical knowledge. Because if you don't have basic electrical knowledge, like we were just discussing, the basic, I think that'll be all the questions. This is the last question. I'm not answering any question. We're moving to the next one. So with basic electrical knowledge, which you can learn mostly in your year one of college, you will be able to discern or even read and have an idea of what the electrical components are. So, and read an electrical diagram. So if you don't have any electrical course which was taken in your college or in your department, whichever you meant, it's going to be a bit tricky, or it will not make sense for somebody to tell, oh, I will give this person an ETR license. So it's possible they give you an ETR license in maybe Ghana, I'm not sure, but you have to apply first and see. I've not seen a situation where they gave somebody without an electrical background. But what they did initially when ETR started, the idea was anybody with secondary school experience can get, secondary school level education can come for the ETR, like attend the ETR class, then go to C, and then, that was the idea. I would try to find the documents and share with Timemo so he can, put that in his records for upcoming ETOs or ETR applicants. I hope that answers your question. Please let's move up to the next question, next screen, so that we can move forward. For the next questions, cadetship, you apply to companies like we all usually do. Munachi, you need to explain why. So moving on to the next question. So, So ETO key responsibilities is to maintain or maintenance of generators and switchboards. So switchboards, generally, personally, I recommend switchboards should be cleaned within every 5 to 10 years, or as you see fit. But cleaning of switchboards cannot be done while the switchboards are live. So what you usually do in practice, from what I have done personally, is to split the bus bar into two, de-isolate all the power, be sure that there's no generator on that side which is running, no 24 volts, and then just clean it out. So there are special electro cleans you could use. Sometimes they are very expensive, so most companies don't buy them. That's the ones you could use on live power switch, on live switchboards, but most companies don't buy, so they use the regular electro clean, electro solve. It's in a green can of about 20 liters. Power it off and clean them. For generators, same idea, but the maintenance is actually done. You mega test the generator. Now, there's a key thing to note when anybody, even if the man says he's an ETO for 25 years, 30 years, he needs to isolate the power to the generator, log out and tag out, which is very important. Then he needs to isolate the AVR, the diodes, the switchboard. Why? He needs to make sure that when he's mega testing something just Google it. There are several videos about it. I could share a video of mega testing later on. You will be injecting voltage into the electric windings of the alternator. While doing that, you cannot inject voltage into something which is connected to another voltage. It will bring a short circuit, and it is very catastrophic even to the human being and the machineries. So until you are sure, dead sure, that a unit is isolated and powered off, you shouldn't allow the guy mega it or do any maintenance. Usually, these things are maintenance of generators and switchboards are usually done by third party, but in some situations where you are offshore, you don't have the materials, or you are worried about your safety and your responsibility, insurance responsibility, you tell them to hand it over to a third party. I was on a ship in 2019. The ship was in dock I think was in Anchorage for about 6 months before I joined. And then I think I was the one who turned on the heater for the alternator. So all alternators have heaters. All of them that I have seen have heaters. They always have. Why? To heat up the windings and reduce the moisture. The idea is to make sure the place is a bit warm so there's no moisture to build up there. I saw the heater turned off and I turned it on. And then I went around. In less than 5 minutes, less than 5 minutes, while I was still taking my round, I had fire, fire, fire. And then I came on, and then there was smoke around this alternator. We switched off the heater because I knew that would have been the only thing. And then we opened it. And, a ship that has been in dock for over 6 months, a lot of soot, that's carbon, has collected moisture there. And it was now like a thick paste of soot. So I wanted to clean it out and then varnish and bake it, So what we call clean it out is you use electroclean to clean out all those dirt. Then you apply varnish to it to make sure you're isolating each winding, each cable winding. Then you bake it with lamp because it's an alternator. We don't need to remove it and take it to the factory. So we put it with maybe a 200 watt lamp for 2-3 days. Now, that job will have been done by me, but at that time, the company was not proactive with spares and everything. And instead of providing me a pressurized gun to use to wash out this suit, they wanted us to use brush, paintbrush to remove all of this. And it was for the whole alternator. So I just told them, please contract a third party, although I supervise the third party so they don't mess up the job. So these are the kind of small maintenance you can make for generators and switchboards. So troubleshooting electrical fault. So before you can troubleshoot an electrical fault, you need to understand how it works. And I think ETOs, sometimes you have it more difficult. Why? Because you have to understand the mechanical side of it before you can even troubleshoot the electrical side of it. Unfortunately, all my colleagues, they will first point to the electrical side before they check the mechanical side. But it's normal because they see it and they feel, oh, this thing must be electrical. It's, for me, I don't pick offense with it. I just go there, understand what's going on, and then I point it out, oh, this one, we need to check this, we need to check this. So, and when somebody is coming to you with problems, you are not going back with problems, you are just here for resolution. Yeah, here for resolution only. You wouldn't have problems, and you keep your mind, your focus on the job, nothing else. Every other thing is extracurricular because your time is limited on the ship. 3 months, 6 months, you pack your stuff and you're out. So troubleshooting, you need to understand the system. First, you check if there's power, checking the distribution board is okay. If the distribution board is even okay, if the breaker is not tripped, you need to check if the 3 terminals or the 3 phases of that breaker is sending out power. Some breakers can just give way. It is on. It looks on. It is looking on. But when you check the voltage across the 3 terminals, you find out that one of them is burnt. So it's possible that happens. So you need to first thing check from the power side. If there's power getting there, okay, power is not the problem. Then you check the switches, the sensors. Is anything wrong with them? Are they misbehaving erratically? How does it work? So for me, the first thing I expect anybody to do is, how does it work? Sometimes, even me, I do skip the diagram part of it. So how does it work first? The only way you can tell how it works, you use the diagram. I skip the diagram sometimes because I'm confident, oh, I know how it works already. I don't need to check the diagram. But at the end of the day, you can end up spending 6 to 7 hours, 12 hours on a job that sitting down for 20 minutes would have, still 20 minutes to study the diagram, and then you just go and attack it. So even when maybe your chief engineer, your second engineer is pushing you, tell him, please, let me have a look at the diagram. Once I have a look at the diagram and you understand what the diagram is saying, then you can approach the job. So I even have a couple of partners that said they would not work on any, they will not, their third party, their job is contracts to get work on general ship repairs, and they don't work on ships who don't have diagrams. So if your ship doesn't have diagrams, doesn't have documentation, they don't come. They don't even come to inspect. They don't come. That's how important diagrams are for troubleshooting. So for understand how it works, and if you don't understand how it works, the next thing is to look for the diagram, comprehend what the diagram is saying. Then you can now check the power. When you check the power and you know how it works, you know, okay, power is not the problem, fuse is not the problem, breaker is not the problem. Then you start knowing the points to check. This is how I expect anybody to, from after this lesson, this is how we should start troubleshooting electrical faults. Know how it works first. If you cannot know how it works, check the diagram, then you check the power, and then you can step by step. That's how it's done, and it should be done the right way. So PLC and automation system. So PLCs, unfortunately, I don't have a PLC with me here, but anyway, you could Google it. There are a lot of PLC videos on the internet. And some people even go as far as taking PLC courses. You can find some of them on Coursera and all of that. So PLC is a small computer system, which when you give a signal, for example, you twist your switch in the control room, or you click your button in the control room, I want valve A open. You click valve A open. That guy sees your signal and then gives an output to the valve you want. And when you give the output, it activates either a solenoid, a switch, whatever. It activates that, let's assume it's a solenoid, which opens the valve. A solenoid that opens the air valve, open the air valve, goes to the valve. The valve turns from closed position to open. And then that open position gives you a feedback, which comes to the PLC again, and then tells you it's a programmable logic control. It gives you that feedback. Once it gets that feedback, it shows you a green signal on your screen, or a green light, or red, depending on the configuration. All these colors of light is depending on what has been configured into your system, or it gives you an open signal. So that is how it works. You give the input goes to the PLC. PLC sees your input that, okay, this man has clicked open. Then it gives an output to the solenoid valve, which opens the air that goes to the final destination where you need it to go. Maybe seawater valve 1. It opens the valve or closes the valve, and then sends the feedback back to the PLC, and then the PLC reports to you, the operator, saying, oh, this is what he has done. So automation systems could be PLC or electrically connected. So when we say electrically connected, you see a situation whereby you start a pump. When you start a pump, it's running, right? And then let's say power fails on that switchboard. The power fails, you see the pump is still running, and the power is from another switchboard is coming. That's switchboard A or switchboard B. It just shows you there's been a latch, electrical latch, whereby even if the power on bus bar A fails, bus bar B can still power that motor or pump. This is usually used for seawater cooling pumps, for generators, so that you don't lose that suction. You don't lose that the pump or pressure, because it will take a lot to build the pressure again. So DPC systems and sensors. We can talk about PLC automation first before we go to DP. PLC automations, you would find PLC automation in your generators, or even in your dry bulk systems, whereby you just need to click the start button, and then the whole process is done by the computer itself. You've sent the input, it sends an output to the valve. From the valve, that sends another output signal, which is a feedback signal. Oh, the valve is open. Then it will start the next pump. Then it will start the compressor. So in some cases, you have some ships whereby if you start the dry bulk compressor without turning on the cooling fan or the cooling pump, the compressor will not run. It has to see the running signal from that cooling pump and fan before it can run the compressor. So let's move to DP systems. Sorry. DP system. So DP is called dynamic position system. The whole idea about DP is to keep the vessel in place by the use of computers. And to do that, this computer has to measure all the external effects on the ship. So the wind, the waves, all of that, to prevent sway, heaving, and all of that. So it has wind sensors, it has MRU or VRU. It also has what else? Wind sensors, VRU, MRU. It also has gyros and gyro systems. Now, the DP system is directly connected by automations and complex computer systems to your power generation system, your generators and your pumps, your thrusters, so that it knows when to demand more power to start up another generator to continue its job. It knows when, the wind, by the calculation of your location, it can calculate the amount of wind that is coming towards the ship and adjust its course, adjust the thrust on its bow thruster, azimuth thruster, and know this is how to maintain this position, longitude, latitude 0708 or whichever is set. But although it can do this job without the help of a human being, you still need an operator to give that initial push, that initial command, and set the point. I want this to be at this longitude and this latitude. I want to keep this position. I want to go 5 meters away, 5 meters towards this position. DP is a very big topic on its own. I hope I would find a time on my own to be able to address that topic. So alarm and monitoring system. So a basic alarm system for a ship, let's just talk about the engine room. I believe we're all engineers here, are the bilge systems. So the bilge system usually made up of switches, magnetic switches or float switches, which once the magnet or the metal approaches the magnet by floating, so water comes, it floats the aluminum metal, which is coated with aluminum float with metal on the inside. It closes the switch or open depending on the configuration of your ship, and then it activates the alarm in the PMS, that's the AMS, alarm monitoring system, depending on how it's used. So power management system can be integrated to your alarm monitoring system, whereby it's an all-encompassing, but the right thing is an alarm monitoring system. So if that's how a small alarm is, then what they just do is they just integrate all of those things. Your sensors are connected to that, open and close. They can send it to PLCs, they can send it to computers, and then all they just need is a feedback. So if they are not getting it, for example, the sensor might be good. But the moment it is disconnected, it will show you wire break or it will show you fault. Then all you have to do is, you understand that this is the sensor. You go there, check. You understand that which PLC is it connected to, because there's always a PLC box for most of these systems. You check. If it's not connected to a PLC, it could be connected to a relay, just like our emergency generator. You see that once the power goes off, there's a timer which is set to 30 seconds. So once this 30 seconds is up, it switches on a relay, the start relay of the emergency generator. So immediately it starts and loads directly. And it also comes to a procedure where if there's no power in the main switchboard to emergency generator breaker, it will automatically allow the generator to close its own breaker to its own switchboard, to the emergency switchboard. So alarm monitoring systems, these are how they are. They are mostly consist of PLCs, relays, and this is how they work: switches, thermistors, temperature sensors, all of that. This is how you can use to monitor the ship. You can use to monitor your generators. You can use to monitor your thrusters. Even electric motors have temperature sensors in them for you to know that, oh, you have been running this motor for way too long and it's heating up. So something is wrong. You isolate it, prevent damage, and investigate. So this is how alarm monitoring systems work. Let's go to the next one. ETO systems on board, maintain switch. I think we've gone through that. Power management system, blah, blah, blah. Okay, good. So let me see if we have a couple of questions. I see we have, okay. I think everybody's dropping their contacts. Okay, good. So let's go back to our lecture. Right, screen 4 now. Main and emergency switchboards. Good. I think I've brushed on this topic already, but let's still just quickly highlight it. I don't want to take too much of everybody's time. Main switchboard is where the main generators are powered. The main switchboard is where the main generator powers. I mean, the main generator of 4 ships, if you can see in this picture here, you can see we have is this clear enough? Who has annotated? Guys, please, let's not annote the page. I'm struggling to even get your annotations off the pictures. So if you see, this is, can you guys see my mouse? Just give me a thumbs up reaction, you will see it. So, but this is DG 1, 2, 3, and 4, right? As you can see, these 4 generators are supplying the main switchboard. This is the main switchboard, right? In this ship, they only have the emergency switchboard. I mean, the emergency generator powering the 440 bus bar. So the bus bar, this bus bar here is where it's called the main switchboard, while this one is carrying the emergency switchboard is carrying the whole of the 440 bus bar. So as such, the emergency switchboard is not going to carry the whole load of the ship. As you can see, or as you saw here, I don't know if this would do a better justice to it. So let's look at this picture. So as you can see, this is bus bar A and bus bar B, bus bar C and bus bar D. This is the emergency switchboard. I mean, emergency generator and switchboard. So now on this ship, the emergency generator can take only the 440 load on board this ship. So the main generator can carry everything quite all right, but the emergency switchboard, the emergency generator can carry only the 440 loads on this ship, which is a good thing because it means the emergency generator can serve as a harbor generator, while you just need the main generators for propulsion purposes only. I mean, propulsion purposes. So it's good and it helps, especially if you maintain the emergency generator room and you emergency generator and you maintain it properly. You wouldn't have issues, and you know that okay, you can do a lot of maintenance on your main generators while your emergency generator is working as the harbor generator powering all your units. So let's go to power management system. Power management systems now has gone into a lot of automations in the sense that you can, once there's a load start, load stop, I think it's in this picture. So in a situation whereby in this picture, we have generator 1 and 4 running. In a situation whereby and azimuth 1 and bow thruster running, in a situation whereby we run the retractable thruster and we run the azimuth thruster 2, this one. If we run this one and this one, and the load that we are getting, that we are demanding from this generator, these 2 generators, 1 and 4, is exceeding what they can produce. They are all rated. Let's not use this specific rating, but imagine your generators are both rated 1,000 kilowatts each, and then you are demanding 3,000 already from both of them. They can't meet up. So because of the PMS system, the power management system, what it will do is try to start one more generator because you still have generator 2 and 3 available. In a situation where generator 2 and 3 are not available to start or they fail to start, the next thing that will happen will be preferential trip. It's always created there. So once it's always there on the switchboard of your ship, it will trip off the non-essential loads or what has been designated as non-essential loads. So it will take them off. In most cases, it starts with the galley, laundry, all those things that life can still continue without for a few hours. We can still continue our operation on the ship without any issues for a few hours. So it usually takes them off. And in a situation, if you look at this picture again, sorry to bring you back to the picture, in a situation whereby the power you are requesting is so low that you don't need 2 generators and the PMS is active, it will stop the generator that you selected as your first stop. In this picture, our first stop is actually gen number 1 because we are running number 4 as the main one. If you see it here, the setting has been pre-selected. It is 4, 3, 1, and 2. So 4 is running, so it's the lead generator. 3 is not running, so you don't need to. It doesn't need to stop. But 1 is running, and the load we are requesting is low. So the LD stop, load stop, is already loading to. You can see this blue, it's already preparing to stop. So if for any reason the load is still low consistently till this blue bar is filled up, gen number 1 will automatically open its air circuit breaker and shut down safely, no issues. So that is one of the benefits of PMS. And this is on an automated PMS. The local ones still do something like that. So it is one of those advantages of PMS. PLC and automation system. I think PLC, we have cleared that when I mentioned the input signal, output signal, feedback. This is what mostly programmable logic control systems do. Automation systems are also of the same caliber. They do them either by electrical connections or by PLCs, which are relays, timers, all connected to achieve a goal of input and output with feedback. So I think we are all clear on that. Navigation electronics. Navigation electronics, I think the most important thing is to know that most of them usually have 2 power supplies. Some could have 220, some could have 220 and 24. Should in case there's a power failure, and then we have to keep the ship, be able to see we should be able to navigate. We should be able to understand that this is how they work, and they should be able to know that, we want them to be able to sail. We want them to be able to tell the direction of the ship. We want them to be able to tell the depth of the ship. We want them to be able to tell the direction of the wind. We want them to be able to tell the stability of the ship. We want them to be able to know our current location of the ship at all times, because it's a risky environment. It is a lot of money that has gone down, and a lot of people's lives are at stake if anything goes wrong. The idea of any seaman is to be able to go to the ship, complete, and come back complete. So all of this, especially navigational equipment, once they fail, troubleshoot, understand how they work, and make it defectly report immediately. No matter how complex the system is, write it. No matter how expensive it is, write it down, but make sure you do your due diligence, put in the effort, troubleshoot, and then find the problem. So fire and gas detection system. Okay. So fire systems, mostly they usually have a main fire panel on the bridge and one in the ECR, or a repeater in a different location. The sensors usually use 24 volts. So, but the main panel is powered by 220. So the panel might be powered by 220, but the individual sensors work with 24 volts, or manual current point work with 24 volts. H2S or gas sensors, depending, some vessels are equipped with H2S sensors or CO2 sensors. They also use 24 volts. This system is quite simple and complex at the same time. It's quite simple if you have studied it and you understand how they work. They usually have loops. What we call by loops is a chain of sensors connected together, which are communicating to each other. So they would, in a good fire alarm system, it can tell you which sensor he's not receiving a feedback from, just from the main panel. And even the repeater to indicate that this sensor is not working. It could tell you, oh, I have a fire alarm there. Somebody has activated a fire alarm. Somebody has broken a manual call point. They are very easy to maintain if you study the manuals, if you have a look at them. And they are also good and effective for monitoring fire flame. So we have a lot of the fire detectors. We have heat and smoke. Most of them are combined together. We have flame. Then we have only heat and we have only smoke. Most places, like the engine room, you have heat and smoke everywhere. Heat and smoke everywhere in the engine room. Then on your generators, you have heat and smoke, and then you have a flame sensor. Same thing with your purifier. So all 4 generators will have heat and smoke, and then they will have a flame detector just beside them, so that if there's any flame, they can pick up the alarm. If there's any heat and smoke, they can pick up the alarm. Why they fit heat and smoke in the rest of the locations is because they are not really prone to immediate flame like that, compared to where you have your diesel generator. Because of the diesel effect, they usually install the gas. They are always installed in strategic locations. Most vessels that have the H2S gas detectors, they are always fitted on deck, on top of the tank tops, so that, or on the main deck, or on top of the tank tops, so that immediately you have any H2S gas or carbon monoxide or any of those toxic gases, you can get the alarms. Usually, the gas detectors are maintained by service centers, which are authorized to maintain them. Although, as ETO, you could just clean them when required or reset the power if you have studied and understand how they work in the manuals. I think that's about it for this section. Let's move to the next sections. So you guys should save your questions. After the meeting, we would really go into it. So electrical cadet / junior ETO. Yes. So electrical cadet is someone who is coming as from college or from university to the ship with his electrical background or electrical relative background, so close to electrical engineering background. The idea of him, for me personally, my advice to cadets and trainees: understand both mechanical and electrical. The ship has a lot of mechanical things. If you understand it, you would not run around a lot. Recently, I was on a ship, and would you believe my pot blower in the engine room, the fan, which cools the engine room, tripped. It was tripping on overload initially. And we reset the overload and it was still tripping. And this time it stopped tripping on overload, then it tripped on power trip. So I disconnected the fan and then started the unit. The main breaker did not trip. Oh, so there's no short circuit inside the system. Then we mega tested the fan from the terminal, from the box. It was looking good. And then we went outside to go open the fan itself to mega test. While we're doing it, the chief engineer decided to go check the flaps. That's the outlet of that fan, where the fan was blowing air out. So it suck hot air and put it outside, or suck cold air and bring. And would you believe these flaps were controlled by a pneumatic system? And the flaps were closed. So the reason that fan tripped, it did not have anywhere to take is discharge to discharge to. So if you are pumping air and it doesn't have anywhere, it will stress the motor and trip. So if you, as an electrical kid, junior ETO, you don't have any knowledge of mechanical, you can be running around, and then your problem is something that is very small. But because it no get wire, you decide that you overlook it, and that is where you have problems. And then nobody will say anything. They will just look at you. You're not a serious person. So for electrical cadets, your position usually comes from your degree, and then you get a job with a company that is willing to hire cadets. Unfortunately, the cadet outreach is not worth it. It has never been easy in Nigeria, and I mean all over the world. I've seen a lot of Europeans move around from country to country to get cadetship. Junior ETO is in the same line as electrical cadets. Once you have a basic background of electrical electronics, you can come in as a junior ETO or electrical cadet. Certified ETO or ETR, you could get the ETR, they will call you an ETO, but in reality, your pay, your ranking will be below the ETO. You'll usually come down under the regulation 3.6. So regulation 3.7 is for ETRs. They call it electrotechnical rating. That's why the meaning is electrotechnical rating. Regulation STCW regulation 3/7. And then certified ETOs usually come as regulation 3.6. So there was a development, I think in the UK, there was a plan to make senior ETOs, that's ETOs who have served more than 5 years, they will come and get a class 1 license, but it has been scrapped. So everybody is still ETO. There's no senior ETO settle or class 1 ETO at the moment. Everything has been scrapped to ETO. But as per your years of service in companies, you can get promoted to senior ETOs. My friends who are on the cruise ships, they have about 6 or 7 ETOs on board. So it's their years of experience that determine the kind of ETO they would take. So specialist role, DP automation offshore. So ETOs, because of the wide range of their knowledge on the ship, because they work with both mechanical guys, they work with both the navigational guys. Most people like to pick them as surveyors. I have one ETO who is currently a surveyor, a part-time surveyor. He still goes to sea, but when he's on time off, he does surveys here and there. And then they are also good for DP surveys because they understand the DP system, they troubleshoot the DP system, they maintain the DP system as needed. So the ETO licensing course in the UK and in Ghana, and I think are 6 months. In Croatia, it used to be 4 months, but Nigerians have been banned from doing it now. For some guys went there and they messed up. The cost of Ghana in total was school fees about $3,000, and then the short course is about another $3,000 or $4,000. So let's just say roughly 7,000. Accommodation is like 100,000 naira a month, thereabouts, for an average house. So let's just say 600,000 plus your $7,000 for school fees and short courses. But there is a very simple way to do it. From my experience and from the younger guys that are under my purview, those guys, what we do is we tell them, go pay the school fees of the 3,000, pay your accommodation. Then once you have done that, you have passed the exam, you come home, raise some money again, then you go and do the short courses and you get your license and come back. It takes time, but I mean, that's the easiest way to get into this. And I mean, for me, most of them, when they get their license, they don't like to work under other ETOs. They like to just be free and then try to do their. But it's usually hard. It's better when you work under older ETOs. You get some small tricks. Some small tricks where then people will see you and say ETO is a magician or is a witch. No. So you can imagine you start a pump and then the pump is just tripping. The pump does not start and it's tripping on overload. and they're telling you, no, it's the overload. And you change the overload, and then the overload is still tripping. And they tell you, oh, it's electrical. But in reality, what's happening is that pump is stuck. So you cannot overcome that load. It's getting the right amount of power. If you check the current is okay. But it is stuck. So when it is stuck, what happens? It will try as much as it can and then trip because there's a safety device there. So that is it. That's most about. And career prospects for ETOs. Most of the ETOs who retire, the ETO program started just recently. I think it started in 2013, 2014 when they started issuing licenses from the UK. Most of them have gone into businesses, and I've seen a lot of them do automation. I've seen a lot of them do marine electrical general repairs. I've seen a lot of them do surveys, DP surveyor. Yeah, most of them are actually DP surveyors. There's career prospects. To be honest, I think ETO on the ship is the only person that has more career prospects than anybody else, with the help of their electrical degrees and backgrounds before coming offshore. That's that. So we've talked about the SCCW 36 ETO certification, SCCW ETO certification. We can say it's ETR certification. So they will call it electrotechnical rating. It's a good certificate for you who doesn't have any seat time and you want to approve seat time for these courses. ETR, I don't think you require to have any seat time. For ETO, you need to have at least 6 months of seat time as electrical trainee or electrical cadet. Electrical and electronics training. So the thing is this, electrical and electronics training, right? If you don't have that degree, it's always a deterrent. And also, even when you have the degree, it might not be a shipboard degree, right? You have a general electronics degree. It's not not shipboard wise inclined. In Nigeria now, only ASLab is offering shipboard training. They have good simulators whereby you can see in reality, what you are seeing on their simulation is almost as real as being on the ship. You can walk around. It's basically like walking around the ship. You could check the feedback and signals. And then sometimes when they have the time, the opportunity, they try to take you on ships that they are working on for you to see in real time what it is like. They usually have a package for ETOs or non-ETOs. I think they do about 10 to 11 modules. Back then, the modules, when I recommended some guys, the modules were 150 per module, and then multiply that by 10 or 11 modules. That's like about 1.2 or 1.3. But now I think there are more. I think that was like 3 years ago. So I think it should be more, maybe double the price, 300 or 400 per module. Now I'm not sure. You can check their website for more. They respond more by email. I think the best thing is just pick their email and send them an email. So electrical fundamentals. So you need to understand that electricity is the flow of electrons from the point A to point B. So voltage is the vehicle that carries current, right? Voltage is the vehicle that carries current. This is basic physics from SS2, SS3, that kind of thing. I know most of us here must have forgotten all those things, but you still need to brush up on those things. You need to also be familiar with Ohm's law. V equals to IR. That basic fundamental knowledge needs to be there so you understand what's going on. You need to understand what single phase means and what three phase means. You also need to understand grounding. You also need to understand cable rating, amperage, voltage, resistance. All of those things you need to keep in the back of your mind. Remember in the beginning, I was talking about the beginning of the call of the meeting, I mentioned that you need to have basic knowledge of symbols, electrical symbols. This will go a long way in reading diagrams. I have met amazing chief engineers that understand how to read electrical diagrams even better than some ETOs. Even better than some ETOs. Some ETOs, there was one ETO that got fired because of just one mistake. Just one mistake. That's why. So people look at it and say, oh, what happened? Their thruster could not start. They were trying to start the thruster. And a day or 2 days before that, they had removed the cooling fan. So normally, most of these Kawasaki thrusters, they put a interlock between the cooling fan and the thruster. So if the cooling fan, the power for the cooling fan was isolated because it has an independent power, they isolated it. And then because they were taking out the fan, which is okay, the fan is actually defective. But because the contactor of that fan was not closing and the interlock was on it, that if the contactor does not close, it's a form of automation. If the contactor does not close, the thruster should not start. He kept on trying left, right, and center. Also, usually there's also an interlock for the seawater pump. If the seawater pump does not start, the thruster should not start. So when the call came out to some of us, oh, our thruster is not starting. We say, check the cooling pump. They say, no, cooling pump is running. Then we say, okay, after like a few hours, okay, does it have a fan? Start the fan. Is the fan running? And the fan is bad. We take it. I say, okay, let the contactor of that fan close first. And then let's see. Lo and behold, they started the fan. The contactor closed, assuming that the fan is there, but it's disconnected. And then start the thruster, and the thruster started. But unfortunately, the company was not forgiving enough. So they had to kick the guy out. So basic fundamentals. If for some reason he had read the electrical diagram and understood that there was an interlock between the thruster and the fan, it wouldn't be an issue. Maybe he even saw it, but he did not understand the connection because he did not remember the symbol for an interlock. So that's where the problem is. So electronics and instrumentation. Electronics are those your green cards. You need to understand the voltages that they work with. Most of them work from instruments work with 4 to 20 milliamps. This is actually a common interview questions for ETO. They will ask you if you know the voltage, the amperage that they work with. Then if you can't remember, some of them will suggest it, especially foreign guys, they suggest it to you and see if you remember it. It is a basic, if you did the electronics degree, you would know that and you will remember it. And even if you didn't do it, if you study a lot of electrical systems, you will notice that, oh, most of them are working between 4 milliamps to 20 milliamps. So PLC and automation, I think we've talked about PLCs. PLCs are programmable logic controls. They are just like small, tiny computers which use your inputs, give an output, and then expect a feedback and communicate that feedback to you, the operator. Automation is also something similar. Some of them, like the interlock we're talking about, is a kind of automation, but it's an electrical automation. That means it was not using any software, it's not using any program. So because the PLCs are programmed, you have to write their language. They are programmed that when you get an input of 1, 0, you should give an output of this, expect a feedback of this, and then communicate it to the guy who pressed the 1, 0. But automations like the interlock, they are automated systems whereby if the fan is not running, it's an electrical automation. So, but there's also programmable automation. The world is moving towards the programmable automation now. And, we just have to get familiar with all of those things. We have to get familiar with them. You need to understand, this is the idea, the basic knowledge, this is how it works. If it's connected to a PLC, then this is how it works. It has a program which is expecting a inputs and going to give an output and feedback to. Fault diagnostics, we discussed about this earlier. We also said the first thing we need to do is understand how it works. If you don't understand how it works, even if you do, the best bet is to look for the diagram, check the diagram, understand the diagram, then check the power. When you check the power, we are checking the power because of the safety. So we don't want a situation whereby you didn't check the power and you want to work on it and then it sparks. God forbid it shocks somebody or electrocutes somebody. It's not going to be one of us that will be caught in that mess. It's not a good one. It's not professional. It's not safe. your family will be waiting for you to come back home with one hand and two hands, and then you come back with half of the hand burnt. That's not a good one. So for diagnosis, understand what the system is used for, understand the diagram, how it works, and then check the power. Then you can go step by step and see what was wrong, understand the behavior. Sometimes, even if it's reported, you need to tell them to start it for you to observe. So you might have a different insight. So for ETOs and generally on the ship, safety awareness is paramount. You can't just you can't just decide that, oh, you go to your job site without gloves, you go to a job site, start a job without measuring the voltage, without checking the parameters. So like the man who was telling us about his generator which switched off, we need to know what's happening to the voltage when his generator is switching off. So that's a part of the safety awareness. You need to be sure what exactly are you starting that your generator is stopping. What is starting that is going on. So you have to be aware of safety. Some people want to work on an electrical system, they don't wear boots, they don't wear coveralls. So some of them will even wear coveralls, and then they want to work on a system and roll the coverall to three-quarter or roll it to short sleeve. It is very, very wrong because electricity can pass through the metal box of your panel box. It can pass through the distributor, and if it shocks you, it takes time for you to recover. It is not safe. It's not smart. You can't be working on a 690 switchboard and you don't wear the long gloves. Each ship should have in their control room high voltage gloves, high voltage boots, and high voltage coveralls with face shield. If you don't have it, fine. You should record it as a defect. Anytime a surveyor comes, you should show that this is the reason. And even if somebody is asking you to do a job on the high voltage systems or the 690 systems, you can easily tell them, no, this is not safe. I don't have the right PPE to work on this system. So it's because it's electrical is not it's a different thing. It's not the same as why? Electricals is not the same as mechanical, whereby you have that's terrible. Whereby you have a system where it's just going to tap your finger and then the finger is swollen or anything like that. So it's not the same. You can get electrocuted and then your heart can stop because your heart works on electrical impulses also. So it's not the same for mechanical or even navigational. So I feel ETOs or electrical trainees should do better. They need to understand the dynamics of electricity and understand the safety hazards in it. So I feel that should be it for this slide. Let's move to the next one. Why choose the ETO career? Well, there's a demand for ETOs, but also there are some restrictions for ETOs. So as you can see, I've been an ETO from the introduction. I've been an ETO for 8 years. If I was a deck officer, I would have progressed to other ranks, right? And if I was an engine officer, I would have progressed to other ranks at this point in time. With my diverse experience, I've been on several ships as listed earlier. But there's a demand for ETOs worldwide. But also, you might also be stuck on the same salary for a very, very long time. So it's not a bad career path, to be honest. It's interesting. Personally, I have loved electrical since I was a young teenager. So for me, it's something I always want to do. I always want to open up systems, check it out, and do a lot more. It also requires you to take a lot of training every few years so you understand what's going on with systems. I know a lot of my friends and colleagues who have taken PLC courses, automation courses, just to refresh their mind because they are a bit older than maybe 20 years ahead of me, 30 years ahead of me. So their electrical degree syllabus was not the same as our own electrical degree syllabus at the moment. So that's just it. So specialized and respected roles. So ETOs, right? Especially when I was on the FPSO, we had 3 ETOs on board. But there was a senior ETO who was like 71, then me as a second ETO. And then we had another ETO who was an instrument technician. So his job was to work on flow meters, sensors, valves, those kind of things. That was his job. So he was not going to be doing the elevator work with us, electric motor work with us, turbine work with us. No, he was not doing that. He was strictly on automation, flow meters, sensors, gas sensors. He was working on that. So yes, as an ETO, you can do that. You can be specialized in that regard. And also as an ETO, it's easy to translate your onboard experience to shore-based experience, although it takes a lot of convincing and proving yourself to people that, oh, you really understand what's going on before they can understand you. Attractive, yes, salaries for ETOs have skyrocketed, but the thing is I would say yes, but I will also say no, because I know a lot of Nigerian ETOs that cannot go outside to work because there's also a age restriction. So the moment you're already clocking your 50s as an ETO, some companies don't want to take you because of the age restriction. Because as an ETO, you most likely will have to climb the Monkey Island to change lamps. But a man in his 50s, you don't expect him to be going to the Monkey Island. So those are the small things that people don't know about the ETO field. And also, being Nigerian, your passport also determines the kind of jobs you can get. So you could hear that somebody is getting this good salary here in one company. Does not mean across board that is what is obtainable. So there are one-offs. And also, you know how the industry is. I believe nobody's new to this industry. You know that there are some jobs that are not, even though it's advertised in Nigeria, the jobs are not given to Nigerians. So a lot of things like that go on. But to be fair, yes, the ETOs, because we are less, and many of the people who even have the ETO license in Nigeria are elderly. I mean, they are above 50 already. Their employment is not so it's not so as strong, and most of them are even retiring. Over the next 10 years, you will see a lot of ETOs retire, so there will be a lot of gap for ETOs. But also then the competency will now be a question. So even the old guys who are leaving will be leaving a gap of availability of ETOs and also availability of competent ETOs. So there are some ETOs that some people don't want to even go and take over from, because they know that these people will not deliver on their job. So it's not so, I mean, to me, it's not so bad, it's not so good. You, as an ETO, you would, over the years, you make money. And if you don't stick to one company, I know one of my colleagues, we were both in Oron together, same class, we did our license same year. And then you see that I have worked on over 8 different types of ships. And his first 5 years, he stayed with a DP1 vessel. First 5 years, one DP1 vessels. And I tried to, we tried to bring him out from there. He was just made up his mind that that's what he wanted to do. So, and of course, if you're a DP1 vessel, your remunerations were different, were lower, experience was lower, all those kind of things. Offshore and DP opportunities. I mean, the whole DP situation highly depends on ETO, more stressful for ETO. The offshore part of it is also good. You will get offers for drill ships, you will get offers for MPSVs, PSVs, Now the whole automations and everything, ETOs are really in demand, to be honest. I cannot say that as an ETO, I have actually really struggled too much to get a job. At least after getting 2 years experience, I did not really struggle. 24 months, after getting 24 months C time as an ETO, licensed ETO, I did not struggle for job. I'm grateful to God for that. But I have a couple of friends aged friends who are above 50, who have been home for 7 months. So you have to make hay while the sun shines. There are still chief engineers who are working at 50. I even had a chief engineer who was working as 60 something. So the other ETO I told you was 71. He's been with the same company for over 30 years. So the company retained him, not just because, although he was old, but they kept him because of the experience he had. So you have to be careful while you're choosing the ETO. You have to make sure you have a plan for the next few years, because over the years, your time might be against you, you know, just like a young girl who is selecting men. So if you are selecting men, by the time she's 30, 40, she will know that time is going. So that's just it. Our next step for experiency, it's you. So for guys who are trying to get in on board as from the cadet level, for me, what I would advise you, apply as an engine cadet. In fact, apply as an engine cadet. No, remove the ETO thing or electrician. Just apply as an engine cadet. Once you get on board, you can now align with the ETO. Sir, I studied electrical engineering. I want you to coach me on this and this and this. You find time, talk to your chief engineer, talk to your ETO, and then find time to learn about it. That way you can easily get into the system, because even with the ETOs, it's not like I've not seen any ETO trainee without connections. So the ETO trainee that worked under me, he was connected to the ship owner. So the other electrical cadets, they were only working for good companies. I mean, when I mean good companies, companies that train cadets like Stars and which other one? Stars is the only one I know that is still generating cadets. They train cadets and then they let the guys go. Some of the young ETOs have even retired. They're not ETOs. ETO Gideon has retired. He has relocated, changed career paths. ETO Washington has retired. I mean, not retired. He has changed career paths. He's working at Shaw now. So a lot of even young ETOs are trying to leave. So there is always going to be space for new ETOs to come in. The only problem will now be a question of your competency, your experience, and all of those things. So as we mentioned earlier, the 12-month seat time, my advice, make it 18 months if you can, which is better. You can join a mentorship program. It doesn't have to be necessarily be me, because I'm also always busy. But you can, I mean, if you have anybody who connected you to this platform, reach out to them, to reach out to some of their ETO friends. Once in a while, they reach out to you by text when they have time. It's not easy. Everybody's trying to make ends meet in life, nobody they flex. You just do what you can. Mentorship program is very, very good. I had a mentor. He was the first ETO in Nigeria to get his ETO license. He got it from the UK. After the first 5 years as ETO, he retired. He's not working as an ETO anymore. He's doing his business. So, that kind of people are the ones that will motivate you to do more and more. So continuous professional development. Like I mentioned earlier, some ETOs, even though they are ETOs, they've gone to do automation courses, they've gone to do PLC courses. Those small things you do, those small courses you do, those will be the things that will separate you from the other guys. I know one that's even done like a survey license. He's a surveyor now. So those small things will separate you from others and then make you a better ETO, better applicant, better employee. So you have more value and you can request for it. And if they tell you, oh, if you say you want Z amount of salaries, and then the person say why they are not, you can boldly tell them, hey, I have this, that guy, whoever you are trying to employ in my place does not have that. So that sets you aside from the others. I think it's one thing that we need to really focus on, because most people just feel, oh, once they've gotten the license, that is it. They just want to make the money. And some people don't even want to make the license. I know a guy, he's been working for more than 10 years. We were trainees together, and he never wanted to do the license. He wanted to do ROV and all of that. And some criminals go ahead to forge licenses, use the license to work, and then later on God will change them when they almost get caught or almost get sent to jail. Then they decide to go and do the original license. So it's better to do the right thing. It's not easy. The best and cheapest way, go to Ghana, take the exams first, pay school fees, take the exams, come back home, raise more money, go take the course. And if you want to do the ETR way, it's okay. But of course, you know, our Nigerian people here, sometimes they can raise some stigma to ETR. But if you are lucky and you get a foreign job to a country where your Nigerian passport can get you, as an ETR, you can still make between 3,000 to 4,000 US, I think, in a month, and then which is still a reasonable amount of money. So, but you have to be competent. That's another thing. So the most important thing, it's your competence cannot hide. If you don't know your work, it is very easy for them to catch you. Very, very easy. Because you most likely be the only one on the ship. You will not have to depend on your second engineer like third engineer can, or fourth engineer. No. So if you don't know your work, you don't know your work. They will catch you. It's quite easy. So I would drop an email where you guys can send in questions or even a WhatsApp message, or WhatsApp number. I think WhatsApp number will be better. I hope if there's time, this is 10 o'clock, I think everybody's tired. So I will just drop a WhatsApp number where in the chats where we can all send me your questions, and MTOs, mechanical technician officers. No, this is obviously a question from someone that's not familiar with the industry. So please, what's going to seek us out? Okay. I will just answer a few questions and then while I'm dropping the number. So the difference between, what did you say? You said the connection between, Hosanna, I'm trying to answer your question, but I can't see the chat right now. Your question was, what was your question again? Oh man. Okay, I can see your question now. It says, what's the connection? ETO or ETR is not done in Nigeria, Mr. Emmanuel, no. What's the connection between sprinkler system and fire alarms? So the fire alarm system, which is covering the whole ship, has selected regions for sprinkler system. So sprinkler system is usually in your engine room over the generators, depending on the amount, and your fuel oil purifiers or lube oil purifiers. So the moment you have a fire alarm in that section, you would, the fire alarm system automatically releases the sprinkler system, activates the sprinkler system to release water down there. So they call them, in some ships, they call them water mist. They call them water mist. They call them sprinkler system. So basically that's how it works. Even ashore, the same thing we're talking about is the same way, right? So if a sprinkler system will always be activated automatically by fire alarm system, by smoke detector or flame detector that has been activated there. So that's just it. I hope that answers your question. So let me quickly fetch you the number. You can send me your WhatsApp questions.
All right. While doing that, let me just give room for probably announcement. We still have like what's the time now? The class the Zoom supposed to end by 10:30, but I will give room for announcement so that maybe you continue from there. And of course, thank you so much for the insightful lecture. I want to believe that all the participants have benefited from it. Even me, I've also benefited from it. On the bridge, I might not be able to go through all the names of everybody that is in the bridge, but we have people from Amano here. We have people from Mining Food Job Arena. We have people from Akwa Ibom State Marina Platform. Then we have external body. So this idea was given birth to when we have an EXCO meeting with Amano, Akwa Ibom State chapter. And of course, I am the chairman of Amano, Akwa Ibom State chapter. So this idea was given birth for how can we mentor our people. And we say, let's make it open since we have some schools that are doing maritime courses. We should not just make it for a manual member alone. So we should make it open so that we can incorporate everybody. You made mention of for CPC. I want to let us know that okay, before then, so I'm now finding it fit to say, okay, let's align with Timemo Global Limited. Since Timemo Global Limited is a CPC provider. Already it's mentioned the CPC mean a continuous, what was the full meaning there? Continuous professional development provider. So should in case we have a course that we probably need to give certificate of attendance, it will be recognized. That was the reason why this okay let partner with Timemo to deliver this. And of course they see it they find it deemed fit to make it open to accommodate other people aside from a manual member. That's why we are here today. Please, I would like to call on my secretary in the person of Engineer Afonimi Iwok to give us brief announcement before I leave the room for Ola to answer a few questions before we call it a day. Thank you. Iwok, please, if you are still in the bridge, you have the floor.
Okay, thank you very much, my chairman. Thank you, Engineer Ola. Thank you very much, also Engineer Dango, and to all our 32 members here present that have deemed it necessary to join this webinar class today. We thank you so very much, and thank you for being a part of this knowledge. Trust me, what you have learned can never be away as far as this industry is concerned. Only had a challenge like this, and you know there are some vessels that you don't have an ETO or whatever. So it behoves on either the chief engineer or the second engineer or the tail engineer to put their heads together and see carry out the necessary tasks as required on board when it has to do with electrical. So whether you are an ETO student or ETO cadet or you're a marine engineer, this class is very, very important, and trust me, it's gonna help us a long way. So thank you very much once again, Engineer Ola, for this insightful class. And we believe that from today, maybe so many people will be reaching out to you, maybe through privately for one support or the other on the cause of the maritime profession. So, gentlemen, this is this class was organized by the alumni of Maritime Academy of Nigeria, Aman State chapter, in collaboration with Timemo Global Limited, as earlier said by the chairman. So please feel free to part of us any day, anytime. And peradventure you are an ex-cadet and you have not registered with the Amano, please I will advise you find a way and identify with any chapter. We have chapters in Lagos, Just, Akwa State, Port Harcourt, and Calabar. So you can identify with any of the chapters. And this is one of our laid-down program for the year. So we have already started. And for this month, we still have something very, very important for us to go home with. So we have started this particular one. So we still have for the month of February receiving a certification and see a documented clinic, mentor sharing, senior officers, cadets, and ex-cadets. And these are very important topics. Safety awareness talk, ISM code, SOLAS, MAPOL basics, all those things. For the month of March, we have technical workshop on marine engineering, electrical, and HVAC and generation. HVAC is a heating, ventilation, and air conditioning and refrigeration system. Technical paper presentation by members, knowledge sharing season as a vessel case studies and other things, brokerage, vessel chartering, and MTIs. So we have a whole lot of things in stock for our members every month. And we are not only limiting the knowledge to the members of the alumni of Amano only. So we share it to the map guy, we share it to the maritime energy and professionals, and we also share it to other maritime bodies. So please and please, we will still like to have you again join our next webinar, and we'll do well to share our links and our dates of those two classes. So thank you very much once again for joining us up. I may not be able to read all the programs we have for the year. But trust me, when next you join us, you will know what will unfold next, what will be our next program. So thank you very much. And once again, I appreciate all of us. So I hope to see more people in our next presentation. And God bless you all. So, Ms. Engineer, over to you for one or two questions. Like the chairman said, class might be ending in the next 30 minutes. So once again, thank you.
All right, before I join, please, if you are an ex-cadet, man info job arena is open for everyone. The criteria for you to join is just your reg number and your portrait picture with phone number, and it will be posted in the platform. If 5 to 10 people identify you, or you'll be added to the platform. Akwa State Marina, that one is just for Akwa State people, but you have to be a Marina before you join, because the form you are going to fill will ask you of your document you have. If you don't have the document complete, you cannot join. Then for a man who, just as my secretary said, as long as you're a graduate of Maritime Academy of Nigeria or you're automatically a member, but you have to register to belong to chapter.
Amano
Then,
is alumni of Maritime Academy of Nigeria, or on.
so you have to register to belong to a chapter. What again? Yes, also, if you are a graduate from university and you read marine, you can join Amano also as an associate member. So that's that on that. I don't know if Engineer Tango is still on the bridge, but at the moment, Oga Ola, you have the floor. Thank you.
Okay, so back So back to our questions, right? I've been seeing a couple of questions. I think some people have even gotten as far as the ACE lab saying 350 to 400. Someone also asked a question saying if he could, there's a software to learn how to study, what do you say, diagrams. So diagrams, actually, for me, from my experience, I didn't use software, but I mean, we're in the 21st century, and obviously there should be some software for that. I would look into it and communicate it with Timemo and see what he can find for you. Someone also asked about sprinkler system and fire alarm system. I answered that question before, but I can also see somebody's answer saying it's about aerosol and all of that. So the sprinkler system on board usually is just water. It's just fresh water, because the idea is to reduce the fire exposure, right? It's not to it's to extinguish the fire. So it's always sprayed in fine atoms. So the water is splitted in fine atoms like a fog. So if you are ideally this is tested monthly. In some cases, people skip and do the every 3 months quarterly. So that's that. For the cadetship, for the licensing pricing, I also made mention of that. The last time I checked, school fees was about 2,500 to 3,000. The only thing that makes it more complicated is the short courses. The short courses in Ghana are a bit expensive, and the requirement for ETO is always a bit expensive because you're required to do high voltage, and then there's exam fee, which is like a hidden fee, which you don't know. But if you take 3,000, you can easily do your exam. 3,000 US dollars. You can easily do your exam, right? Pay your fees and do your exams. But bear in mind that accommodation in Ghana now has skyrocketed to 100,000 per month, excluding feeding. So we are looking at maybe 200,000 a month or something like that for 6 months. Write your exams, come back home, raise some money. After like 6 months, you go back, or 1 year, go back, get your license. And then, you build competence, build credibility. Then which other questions? I think that's about it. Please, I need a link for any company that accept trainee ETO. To be honest, links to trainee ETO, it's like I said, I've not seen any company that is taking trainee ETO. Most of them take cadets from the maritime colleges. It was in the early stages in 2014, 2015, when there was a requirement by IOCs, that's the oil companies, to have ETOs, electricians on board. That was when most companies like Slock picked up about 5 or 10 electricians that were competent guys, or guys that had degrees. And then they brought them on board, trained them, and then they made them like electricians who then went for their license when Ghana started the licensing thing in 2016. So yeah, that's about it. Then someone said, for someone with a degree in electrical electronics, STAW, SAS, SAAS, and PCRB. So yeah, I think I answered this by chat. I said yes, your papers are okay, but they vary per company. I meant companies, not I meant companies. So depending on the company you are talking to, some will pick you for that amount. And the only thing I find is that most of the people who come in as with electrical engineering degrees and basic jobs are not always happy with the remunerations as their trainee ETO or all of those things. But for the ETO now, everybody's really hung up on the licensed ETO. And even for us, I remember when they were asking, do you have what do you call it? They were asking if you have 24 months experience. So, I mean, this also drove a lot of young guys out of the industry, because every time you cross one bridge, there's always another bridge to cross. So, like the engineers mentioned, they say you have to have CPC. So you have to do some automation courses, just make something to make you stand out, be distinct. So, I mean, for example, right now, I personally am getting offers to go to other ships like MPSVs, but I'm sticking to my hybrid ship. And there's a reason for that. I'm sticking to the hybrid ship because, one, it is the latest thing closest to the new technology coming. The new technology coming is going to be autonomous ship. BYD, the Chinese car company, just launched a hybrid ship, which is almost fully autonomous. So if I have the hybrid experience for 1, 2, 3, 4 years, I should be among the select few that would have access to ships like that. But if I had gone to the MPSVs or PSVs, which are offering better pay, and I mean longer contracts, I will make more money, but I am not looking at the current pay of what this new these MPSs are offering. I'm looking at the hybrid ships. So when somebody asks you, oh, do you have any idea of energy storage units or hybrid ships, you can easily tell them, no, this is what I've been doing, and this is something I've been doing for years. I have hands-on experience on how to do it. So, and you also have the connections with the service techs and all of those things. So it makes your life a bit easier. So if anybody has, okay, how can I join Amano Group Marine Engineering at school at Delta State Marine Poly? I am done with ending, now looking for careership on board. I think this is a question I would like Timemo to answer it. So there's a lot of politics in the schooling and the maritime colleges and stuff like that, which personally I like to stay out of, because I have a couple of friends who must have studied in this school, and so and it's one thing to have the degree or the diploma. It's another thing for it to be recognized by the Maritime Authority. So that is always the misconception. So Delta State Maritime Polytechnic, I will have to look into your school to be sure. So I have also dropped, I also saw a suggestion whereby we should create a WhatsApp group where people can ask questions and then we can answer them there. I think that would be a very good one because it will be easy for everybody, for me to just take time. It might take weeks, but at least you know that you can get the answers, your answers to your questions. So Mr. Peter said, please, I can one enter the industry via other departments just to obtain seat time before going for the ETR. So what other departments? You mean deck or engine? So the thing is, what you stamp on your discharge book matters to the Maritime Authority. So I think I've answered all the questions so far. If there's none, please say. And on that note, I will hand over to the chairman of this event.
All right, thank you so much, Stola. It was nice working with you, and when I shared the idea and you key into it, uh, that was a good one. Can you imagine when you're on board that your second engineer is an ex-cadet, third engineer is an ex-cadet, ETO is an ex-cadet? You know what that means. So it's already formed team delivery, regardless of the condition of the vessel, but we always say to deliver.
I'm back.
So,
Already, let me know.
all right, welcome back, sir. So we have just 7 minutes for this class to end. So I want us to at least use 5 minutes. And we use the 2 minutes to probably do a screenshot and shut down from here. If you have not dropped your number, your email in the chat box, please kindly do so. We have a WhatsApp platform that it's a general I'm going to add you to, and I'll also add Okaola to that group so that if you still have a question that is not being touched, you can ask there and he will answer at his convenience. At the moment, Oga Charles, please, you have the floor. Thank you.
All right. Thank you very much, ETO. We appreciate your deep insight. I just remember myself back then, and I was so in love with electronics then, and he rekindled some kind of knowledge on me. I've been away from sea for about 2 years plus now. So 2 years is like 2 years is like forever, So regarding the WhatsApp platform that some people asked, don't worry. Engineer Bong is going to share with you the link to a training platform, which of course that will be for all your queries and all information regarding the next training sessions. And we hope that you key into that and also support what we are doing. The essence is that very soon you have a platform where you can go in and take your course and download your certificate after making your payments. That will be easier for self-study. Only when you're available, you can take it at space. So other than that, we appreciate everyone for joining, and I appreciate the S-cadets here. I can see some of my old-time friends on the platform and some of my cadets here that have grown to be chief engineers. So thank you very much. Till we see you on the platform, and we hope that you all register and take advantage of what the innovation that Timemo is bringing to the maritime space and maritime industry. Thanks to my prodigy chapter, Akwa Ibom State chapter. It's my chapter in Proxy. I've been part of it right from day one till date. I think they don't want to leave me to go, so I've accepted as member. So thank you for always coming through and having your members at heart, and that's always been the dream. So thank you very much and have a wonderful week ahead. From me to you, I say God bless you all. Thank you.
Please, can we do a screenshot? Who's going to be our cameraman? Let's turn on our cameras while we do a screenshot. Who is a volunteer to do a screenshot for us? Anyone will do that? Do we have anyone to do a screenshot for us? I'm using laptop. I don't know what to do from here. Anyone that can do a screenshot for us? Anybody?
Yeah, that's screenshot.
Can you turn on your camera? Let's do a screenshot. Who is doing it for us, man? Anybody, can you do that for us?
Okay, Chief. Everybody are there. So we are still waiting for some people to turn on their cameras. Okay, I've taken few shots and I will drop it on the
Everybody
group.
can just go ahead so that we end the class. We have 3 minutes to go.
Yeah, I'll drop it on the group, Chief. I've taken few shots.
I make sure you did not take yourself alone.
Engineer Bong, so when will they add ETO to my name too?
You are just starting now.
They should tell me the time so that I can fast forward. Accelerated class.
Next week.
Okay, next week. Next week, Monday. Digital. All right. Thank you very much.
All right, thank you.